Thanks for joining. John here, software engineer with 10 years of experience. And a Leetcode a day keeps the poverty away, right? I am working on the latter Leetcode Kata. I don't do this every day, but yeah, definitely once a month and maybe even once or twice a week. Laterally Leetcode Kata is the problem set described here. Standard set includes, and so this builds on top of the blind 75 and the grind 75. So it's telling you what Leetcode questions to practice to cover a broad set of patterns that will be covered in technical coding interviews. And you can see about the actual percentage of coverage if you read through the article, but basically there's 20 problems. There's 20 problems in the expanded kata. There's 12 problems in the standard kata. Do I not say the word 12? 12. Yeah, there you go. Okay, in the kind of section prior. So yeah, so we start off with two sums. So let's get into it. The idea of the kata is that you do these pet problems over and over again so that you can basically sort of memorize them. It's like a memorization-based approach. Okay, so we are going to get rid of all of this, and we want to read the problem, read it every time. I don't care if you've read it 100 times. Read the problem, and then we will say the overall approach details out loud before diving into the code, just like you would in a real interview. So we want to put ourselves in the place as if it were a real interview. So let's read. Given a one indexed array of integers. Oh, I'm not sharing my screen. Let me share the whole screen. By the way, if you're on TikTok, you can go over to YouTube or Twitch and see the whole screen. And Leetcode has this cool like dynamic view now. See how I can slide that? This view is new. I think it's really great. So if you haven't been to Leetcode in a while, check that out. All right, let's start over. Pardon me. Given a one indexed array of integers, numbers, that is already sorted in non-decreasing order, find two numbers such that they add to a specific target. Let these two numbers be called numbers index 1 and numbers index 2, where 1 is less than or equal to the first index, less than or equal to the second, and then less than or equal to the numbers dot length. Tests are generated such that there is exactly one solution. You may not use the same element twice. Your solution must use only constant extra space. And by extra space, they mean memory complexity. Okay, so let's write out our notes. We're going to say initial note. Sorted in non-decreasing order. Should target constant memory. Okay. This is just based on the input, and then one indexed. Result is one indexed. Elements that sum to target. A valid result is guaranteed. No need to handle sad cases. Okay, so those are some initial thoughts. Given this, use two pointers, allowing perf time complexity, allowing worst case time complexity, O of n. Okay. Which level of difficulty are you doing? This is a medium, but I've done this problem so many times that it's easier than an easy. Like solving this medium is easier than trying to solve a new easy that I haven't seen before, by far. And this will be the case even for hards as well. If you walk through the kata and you repeat the hard problems, you will find after just going through it a few times, not the first time, but after you go through it a few times, getting a hard problem similar to that one is far easier than even doing many easies that you haven't seen before. That is the cheat code of the kata approach. Okay, so we need to have a left index, which is going to initialize it right. And then we want to have a right index, which is the length of the numbers minus 1. Okay. And we will eventually return left index plus 1. Remember, we're 1 indexed in the response. Right index plus 1. And we want to while until they cross. That is the approach here. So while left index is less than right index. Because we cannot point at the same element, then we don't need to handle the case where the indexes are equal. We can use a strict less than operation. So we will get the left val is numbers index left IDX, and the right val is numbers index right IDX. Okay. And we just add them. If left val plus, and actually we can do a current sum so that we don't repeat ourselves. Cur sum is left val plus right val. Okay. Thanks for the follow. So if the current sum is less than the target, we want to move the left pointer to the right to increase the overall sum. Left IDX plus 1. Else if the current sum is greater than the target, make sure we get our colons on there, then right IDX, I think I can do minus equals, but whatever, this will be fine. Equals right IDX minus 1. Else found a match. And we will return this expression. All right, let's try. Invalid syntax on the elif cur sum. Let's see what the issue is. I put a colon there. I shouldn't have done that. Hey. Can I still code, or do we need to wrap up?
I'm just going to cook dinner.
Is it okay if I code while you do that?
Yeah.
Okay. All right, so this is the correct answer. So there you go. That's the first problem. And the question in the chat, are you more familiar with Python, or is the language a strategic choice? The answer is yes to both. So there's an argument to be made that I know JavaScript a little bit better, but Python, I mean, if you asked me 5 years ago, I was much better with JavaScript. But today, I'm pretty much roughly equal with the two. However, Python is, if you're equally good with JavaScript and Python, Python has notably more useful built-in data structures, like the default dictionary would be one example, or the ordered dict, which is built into Python. Some of these things you would have to write by hand in JavaScript, which is not impossible, but it saves you 5 minutes, and 5 minutes in a whiteboarding interview is actually a big deal. And even the looping syntax. So your for loop in JavaScript, you're going to say for I less than length, et cetera, et cetera. And here I've used a while loop. And so the while loop length difference isn't very different between JavaScript and Python. But if I'd had to do a for loop, you're able to write them more tersely in Python, depending on the kind of for loop. So the for const in like for x and y in JavaScript is pretty terse as well. But I was thinking of an iterated, like an integer indexed for loop is what I was thinking of specifically. Very cool follow. Thanks. Oh, so it makes the problem solving faster. Yeah, basically that is the reason. Yeah. Okay. Quick reminder, if you're on TikTok, you can go over to YouTube or Twitch and see the full screen. Link is in my bio. Thanks for the follows. Let's move on to the next problem. Laterally Leetcode Kata, you start with twosum, and we want to create a pattern level flow or a meta flow. The way we do this is by grouping similar problems, putting those in adjacent order in the Leetcode Kata. So in the standard Kata, we start with twosum. This is not the easiest form of twosum, but it is a really great watermark because we're assuming you actually have the easier ones with the hash map already done. You already know those to even get this far. And then once you've done this one, it moves naturally into 3-sum. If we go to the expanded kata, there is an additional 3-sum closest, which also uses 2-sum. It would be good to do write out each of the 3 solutions, 2 pointers, hash set, and no sort. So if you can do no sort 3-sum, you can also do the standard 2-sum. I think it would be good. Okay, and we do this in the standard way as well. I forgot about that. Okay, so when we do 3-sum, we're going to solve it optimally, but we are also going to write out the alternate and or suboptimal solutions. So no sort is optimal if you can't sort, but it's suboptimal if you can sort. So in an interview situation, you would want to speak about it, but not run it. You would want to speak about it, but not run it. Okay, let's get into 3-sum. Here's the standard 3-sum. Given an int, let me wipe the background. And I typically leave this top portion, has 2 solutions, 2 pointers. This is like a reminder to me, basically. You can wipe that if you want to, but I typically leave it. Anyway, given an integer array nums, return all of the triplets ijk such that ij and k are different indices, and yet their sum adds to 0. So we're not given a target in this case. We assume a target value of 0. Notice the solution must not contain duplicate triplets. And that's with respect to the indices. The values may coincidentally be equal, but they will be equal because there's a 2 at position index 1 and there's a 2 at position index 2, as an example. Ultimately, we are returning the values, not the indices. And here you can see that in the output, there is a duplicate value in the output, but that is not a duplicate index. Okay, so that's maybe a nuance that could be missed if you're not familiar with 3-sum. This is one of the benefits of Kata, by the way. Beyond just being able to write the code quickly, you become familiar with the conventions of the problems, which makes you appear very smart to the interviewer, because the interviewer may misspeak, and you'll be able to proceed in spite of their bad hint or bad speech. Which makes you look very impressive, because interviewers do reflect on the fact that they screwed up. And they will often be aware, and they will often be impressed by a candidate who was able to proceed in spite of the fact that the interviewer did a poor job. Okay, so let's do some initial thoughts. 3-sum is conceptually 2-sum with an auxiliary loop, with an extra loop. The cost is a power per extra loop. So n squared target time performance in this case. We are not given a sorted list, but sorting is cheaper than n squared. So we should start by sorting. Then, given a sorted list, the inner 2-sum can be a 2-pointer approach. Memory here is constant because the list is sorted in place. Okay, so that's the overall approach and the aspirational time complexity and memory complexity. We begin creating results, which is a set. Use the set structure for auto deduplication. We're going to have a write index. This can also be called the wrapper index, because we're in this extra loop that we have. There will only be one of them. It's strictly moving left to right. Only the inner 2-sum is going to have a left and a right. So there's going to be 3 pointers, 3-sum, 3 pointers, but the auxiliary loop is only a left to right loop. Does that make sense? Thanks for the follow, Alex. So I'll call this the wrapper IDX. We're going to initialize that to 0. We're going to say while wrapper IDX is less than the length of nums minus 1. So this wrapper, this meta layer, is doing a 1 pass, which means as long as the wrapper index is less than the final element, that's our exit condition. I'll say to do here, then I'll say return results. And we know we will call self, we don't need to use self, but we'll call toSum under some condition. So I'm going to go ahead and define toSum. You can put it on the class if you want, it doesn't matter. So what is toSum going to need? We're going to need to pass the numbers and results. We'll call it nums results. The start index and the end index. Okay. So for this toSum, oh, we also need a target. That's right. Nums results target. Say left IDX is going to be started at the start IDX. Right IDX is going to be started at the end IDX. But we'll be moving left and right. We won't be moving start and end. You could recycle start and end if you want to, but I think it's less confusing to segment them out. So then we'll just do the toSum like we did previously. And this is while the left index is less than the right index. If greater than, this is pseudocode right now, elif less than, else, match found. We always know the append order because it's always going to be left, current, right. So we don't need to sort that subarray. We always know it ahead of time. It's going to be left, current, right. So we will say results.append, and then we will fast forward on duplicates. And I'll say that's to do. Success response, I have to sharpen my Leetcode skills and understanding of the current market. Yep. Yeah. If you're interested in the middle of the market, you don't need Leetcode. But if you're interested in top of market, it is table stakes. Unfortunately, I wish it weren't so. Okay, so match found. Here we append results LCR. So we can say left IDX, current IDX, right IDX. Okay. Okay, where is current? This is actually not right. This is not right. This should be left IDX is in the middle, because further than the left of my toSum is my wrapper index, which is going to be further to the left. So wrapper, left, right. So start index should not be start index. It should be the wrapper index. And then the left is wrapper index plus 1. Because I'm doing this meta loop of left to right, I never need to reinvestigate to the left of the current wrapper index. Do you see how that's saving me cycles and that's simplifying the inner problem? So I only need to look, my toSum is only concerned with the shrinking window from the wrapper index to the end. Okay, so wrapper index, left, right index. Here we'll do left val is nums left IDX, right val is nums right IDX, cursum is left val plus right val. Greater than what? If cursum is greater than the target, then we want to reduce the current sum, which means we want to take the right pointer and move it to left. So right IDX minus equals 1. In this case, the reciprocal left IDX plus equals 1. Okay. That will be when cur sum is less than the target. Chat says, what language are you using? The answer is Python. Thanks, Bob. Yep, yeah, Bob answered. And oh, we got thanks, chat. Chat helping each other out. I love it. And thank you for the likes. If you're enjoying the video, tap like some more. Obi, how do I get internships? I'm a comp sci major. Have you tried applying? Have you tried applying? The answer is first you get an interview and then you pass the interview. And how do you get an interview? Social networking, application, building your portfolio. Those are some of the steps. Feel free to book a consult with me at ladderly.io. Link is in the bio if you're interested. It's a pretty straightforward process to get an internship. The reason that I see some people failing to do so is mainly because they haven't done enough volume on the application. That's the main mistake I see. They haven't done enough volume on the application. Are you doing 80 plus applications per week? It's a competitive market. Dan HP, how many languages should I learn before start applying for internships? 1. You only need 1 language. Do not gatekeep yourself. That's another big mistake that I see. You only need 1 language. Okay, let's continue. Good questions in the chat. Left index, right index, we did this. We need our else condition. So else, the match is found. We append, and we've got the correct append there. Oh, it should be add. Because it's a set. Results is a set, so we add. And we want to add the tuple, because the tuple, notice I'm using parentheses, is serializable, it's hashable, and it's able to be placed into a set that way. The list would give you a problem. And then it says to do, oh, the fast forward, we need to do that. So how do we do this? We can fast forward on one of the sides. We can fast forward on one of the sides. So let's fast forward on left, because why not? It actually doesn't matter. You could do this either direction. So we'll say left idx plus equals 1. And then we'll say left val equals, we don't even need to do the whole sum. We can just check on the value itself. So let me do priv left equals left val. Okay. And then this will be nums again, left idx. So we've moved the left pointer. We have a reference to the old value. Now we have the new value. So if priv left is not, or if priv left is equal to left val, sorry, not if, while. This is how we're going to keep moving until we're done. So while priv left is equal to left val. In fact, I can even take these 2 lines and move it in here, I think. I might be wrong about that. Let's check. So priv left is equal to left val. And then while they're equal, we're going to move the left hand and reassign the left value. I think that's right. I think that's right. And that will basically fast forward the duplicates. Great. By the time we are done with this, we will have interrogated the entire shrinking window to the right of the wrapper value. And so we're ready to increment the wrapper value. So we don't need to return results because it's modified by reference. Okay. So here, all that's left to do is if I need to do an initial check. If not, 0 space. I'm going to call it 0 space. I know that doesn't make sense. I'll be right back. I'll fix that in a minute. Do toSum, and then after we do the toSum, we simply increment the wrapper idx plus equals 1. Let's pass the arguments properly to toSum. We have nums, which in the outer loop is called nums. Great. Nums results the target, which is the opposite of the wrapper value, because we want all three elements to add to 0, which means the two sub-elements have a target, which is the opposite of the wrapper value. Does that make sense? That's one of the ones that once you get it, it's very easy, but getting it the first time, you might need to think about it a little bit. Go ahead, take your time on these kata. So that is just the opposite of the wrapper value, which is nums, wrapper IDX. That is the target for the two sum. Okay, so we have, and then the wrapper IDX itself. And then the nums length, or like final index. Final IDX is nums -1. And that should be the rightmost index every time. So it's the end. Here's the end. Just double checking the arguments. The wrapper, the target. We're comparing to target. Great. Results. We add to results. Nums. Great. This is looking good. So the zero space thing is the last bit, and then we'll be ready to run. So what is that zero space thing? We're just checking for duplicates again. Just like within the two sum, we are fast forwarding on duplicates. We also want to do this in the wrapper loop. Suppose that in the inner two sum, I fast forwarded my left index so that my left is now different. I want to also move the wrapper so that the wrapper value is different. Otherwise, I will re-explore the same set of values that I just checked in my two sum, because the target will be the same. Does that make sense? So there's two levels of potential duplication in this three sum. Wrapper val, or cur wrapper val is nums, and we'll look up the wrapper IDX. Can I move this out here? Why not? So here's the current one. And the exception is if it is 0. We will not have priv. That's the exception. So here's priv wrapper val. I'm doing something wrong here. If not, wrapper index. If the wrapper index is not 0, is a much better way to say what I want to do. If the wrapper index is not 0, and the wrapper value is not the previous value, and we want to hide it behind the and, otherwise my left is out of bounds. At the 0 index, my previous is out of bounds. That's the problem that I need to be careful to avoid. Does that make sense? When I'm at the 0 index, I can't check the previous. That would be out of bounds. So that's why I have this exception. So I don't actually want to assign a variable to avoid that edge case. I'll just put it behind this and. So when the wrapper index is not 0, now I can feel free to look up a -1 index. And nums is not equal to cur wrapper val. The idea here is priv. So that I have a new wrapper value, not just a new wrapper index, but a new wrapper value compared to my last iteration. Great. I think we have the deduplication. Let's run it. Oh no, we're too slow. What can we do to speed this up? Was that the final run, or did we exceed even the we exceeded even the initial test cases? Okay, I think we exceeded even the initial test cases. So I think I have a problem here. While the, or am I not incrementing this? I think I need to dedent that. Let's see. So we have a wrong answer. So what is the issue here? Oh, I didn't sort it, did I? Okay, nums. Nums.sort and log in. Not a binding change to time. Okay, so what is the issue now? The issue now is that I've written 1, 3, 4, and I should have said -1, -1, 2. Well, 1, 3, 4 do sum. 1, 3, 4 do sum properly. No, they don't. Where are they coming from? One, there's no. Okay. How am I even finding a 3? That's interesting. How to math in general correlate to CS? Asymptotic analysis would be the one that we're doing right now, but in general, it's just because you're going to be programming equations sometimes. So there's a major problem here somewhere. Let's look through it. So I have my wrapper index, then here on the left. So let's step through it. That's the best way to do this right now. Nums, all right. So it should be -4 up to +2, okay? My wrapper index is a 0. The final index is the length of nums -1. That looks good. We sorted. So let's say here we're starting with 0. Length of nums -1. I can dry that up. It's a little bit better. So 0 is less than 1, 2, 3, 4, 5. Great. So here's the current value, which will be -4. If here's the index is not equal to 0, okay? The index is equal to 0. The index is equal to 0. Because the index is equal to 0, we are skipping running to sum. This is a problem. So we are skipping maybe I should say or. So what if I do this? If I do this, now I will trigger to sum on the 0 index, but I don't have to worry about the left out of bounds, which was my initial concern. Okay, so this could solve the problem. Let's take a look. List index out of range. Where are we out of range? On line 51. Okay. While previous left. Okay, right. We need a another condition. So while previous left equals left value and left IDX doesn't go out of bounds. I think we need to do a less than or equal on that index. We don't want the or equal. Okay. We don't want the or equal. All right. Well, we still screwed up. So let's see what's going on now. So here we are in the 0 case. We pass numbers. We pass results, which is an empty set. We're passing the target, which will be 4. So I should go in with -4 and 4. Oh, is it because I'm, nums results target wrapper index end index. All right, let's keep going one step at a time. So I call to sum. We want a target of 4. Now we're going to start looking at the value of -1, and we'll end looking at the value of 2. And I shouldn't find any solution here. I shouldn't find any solution. but I'm reporting a solution. Somehow I'm worried about my target being either flipped or appended. So if the sum is too big, I'm moving my right hand to the left. If the sum is too small, I'm moving my left hand to the right. This looks good. Otherwise, they're equal. We found a match. That looks good. Okay, so I think we're falling through properly when the current value is -4. And so the current target is 4. All right, so let's look at the next case. So the next case, it's -4, and then it will be -1. What are the values we're returning? The values we're returning are the values and not the indices. I think that's my whole problem. Let's take a look. Results.add. I want the wrapper value. And then the left value and the right value. Takes exactly one argument. Okay, let's wrap it into a tuple. Cool. All right, so the issue is that I found the right indices and I was returning the indices instead of the values. And that wasn't a problem reading the problem because we read it, but it was a problem of being continuously mindful of the end goal. So drop the ball on that and look how much time it cost. What problem is this? This is 3 sum. So now the interviewer says, great job, but now imagine that you are in a situation where you can't sort. An example of this would be that you are sending and receiving events over time. I'm going to bring down my chair because I want to sit. Sit to stand desk for the win. Rob, what's up? So now the interviewer says, imagine that you can't sort. What would you do? In a situation where this might happen is if you have a server and a client and they're making requests to each other over time so that the server is never at one point aware of the entire list of nums. They actually are not serially passed. They're passed asynchronously, and you need this function to execute many times. So what you can do is you can hold a hash map in memory. So that basically we can refactor this to use a hash map. And that will increase our memory cost. But interestingly, it does not decrease the performance, the runtime. So the runtime will be just as good. It will still be n squared. And the trade-off is that we have to pay an extra power in memory, Leetcode is the devil's work. I don't disagree. Okay, so we are going to wipe this and do it from scratch. Now, suppose we can't sort. So we should use a hash map. Perf is still O of n squared, but now mem cost is O of n. The bean, honestly, it's literally how well can you memorize this? That's right. That's right. So potentially you can't sort, so it's every possible unique combo potentially. No, you do not need to do O(n) cubed. That would be fine as sort of like a naive thing to say. Like you're not going to get in trouble for saying that, but you need to be able to think through the fact that it's reducible by a power, which is actually a big deal. Different interviewers might score you differently. If you do implement an O(n) cubed brute force, if you're speaking well, like if you're speaking clearly enough and you've simply missed a key, you might pass the interview at some level. But at a senior level, it will be frowned upon, let's say. In big tech interview loops, it's actually rare that a single mistake will cost you the whole interview. But what it will do is it will add negative signal. And you only need like 3 strikes and you're out, basically. Okay. So we're still going to do an outer loop, but the inner 2 sort will be using a hash map. So here we'll say results is a set auto deduplication. That's why we're picking the set, and we will add in the tuple. 2 results, we have a wrapper index, which we initialize to 0. And then we have the final index, which is the length of nums minus 1. We're going to say while, and then eventually return results. Here we're going to run toSum. If allowable, check duplicates, and skip 0 index on check. Thanks for the follow. And then toSum, we'll go down and define toSum. So here we have nums, results, target, start IDX, end IDX. Okay. In this approach, we'll make a scene map. This will be a dictionary in Python. You might be able to use a set here as well. I don't know. I hadn't thought too much about it. The left IDX is, and we don't want the start IDX there. Here we want the wrapper IDX. And so the left IDX is the wrapper IDX plus 1. And then the right IDX is the, nope, we're not doing 2-pointer. See, there's that autopilot. How do we do this in the no sort is I think we move left only. So we have the wrapper index, and then we have the, we can do left. We can still call it left. Left IDX, wrapper IDX plus 1. And if I'm not mistaken, we simply don't have a right. Or we do, but we can't move it. So while left IDX is less than end IDX. To do, and then do we eventually need to return? No, because we are going to modify the results by reference. Okay, so we still want to calculate the current sum and compare that to the target. I think I can kind of ignore the end index here. So we have the cur left, which is nums, and we're going to look up the left IDX. Okay, now that you have cur left, we can say needed or sought is target minus cur left. Okay. If scene contains sought, we have a match. Else, we are going to store it for a future iteration. Scene. Do I want to say that I've seen cur left, or do I want to say that I've seen something else? So what I'm seeking is my target minus my current left. Let's say that I'm on the 3rd iteration, and target is 10, Current left is 5, or no, let's not use 5 because that'll make it the same reference. Current value is 6. So I'm looking for a 4. That 4 that I'm looking for, is it a previous iteration target minus cur left, or is it just a previous iteration cur left? That's the thing I'm thinking through. The answer, I think, is that we just want it to be the previous iteration cur left, because otherwise it seems at first glance we would be double counting the target, which seems like we don't want to do that. Movie Man, what's up? Thanks for the follow. So here I'll say seen cur left. And I can just say it's true or it's 1 or something like that. Which is evidence that we could use a set if we're setting the value to be a flag, as opposed to setting the value to be a meaningful value. So I'll say to do could be a set, I think, but I will proceed as I was thinking about it previously. And I'll just call this true. Okay? So, and if we have seen what we sought, then we are going to results.add this tuple. And the tuple is the wrapper value, left value, right value. So the wrapper value is nums. We look at the wrapper IDX. The left value will be whichever is first seen. Whichever is first seen. Which I think is to say the sought value. And then finally the cur left. Okay? To do fast forward dupes. And otherwise we are good. Okay, so let's fast forward the dupes. I'll pick the left hand, since that's the only one that I should be manipulating. So here I will say priv left equals cur left, while priv left equals cur left. So this should immediately trigger. Then we will move the left index. Okay. And we will set cur left to this new value. Cur left equals nums. You can see the brain juice is fading. Is nums, and it's the left IDX on nums is now our cur left. And that should just fast forward some duplicates. Okay, now we have returned up so that we're done here. Let's see, we have some comments in the chat. Can you do target minus cur index value and see if that result exists in your list? Could be a single pass. Depending on what you mean, I think that is exactly what we've done. Depending on what you mean. So when you say target minus cur index, I think you actually mean target minus cur value. And you do say cur index value. So I think this is basically the expression you're referring to. And then you say, see if that exists in your list. And that is exactly what we've done here, if I understand you correctly. Good question. JavaScript is too hard, bro. Well, this is Python. So either take that as encouragement to jump in, or maybe run away from Python and reconsider if JavaScript's actually okay. Show us how to. When coding Python, you should try to follow PEP 8 standards and use snake case, not camel case. Yeah, it's a good point. And I think I've mixed it here, have I? It's a good point. I will tell you in an interview, no one cares. No one cares. But I will say in your code base, you're absolutely right. It's a good point. What is your output for this piece of code, or is it connected to something? We can run it. It's just going to crash right now. So the output will eventually be, here's some example outputs, something like this. It'll be a list of ordered value lists. Don't they only hire young people? No, that's not true. There is age discrimination. There is a bias. No cap. It's real. Own it. Let's own it. Let's fix it. Let's own it. You can't fix it if you don't own it. So it's real. But bias doesn't mean they only hire young people. When we talk about the bias, this is like a few percentage points of unfair advantage to young people. The bias in magnitude is like a single digit thing when it comes to age discrimination. It's non-linear. It depends at like which age specifically. Like if you get really old, frankly, there's a huge discrimination. But anyway, on average, it's not that big of a deal. How about Java? Is it easy to learn? That's a tricky one. Java can be easy to learn. It can be easy to learn. I do not recommend or enjoy using Java for your Leetcode or your coding interviews. I think it's verbose. It takes too long. It makes interviewing really hard. But if you're talking about learning it, if you're not talking about interviews, if you're just talking about learning, even there, man, it's not good. It's not good. You don't want to start with Java because it introduces concepts that you actually don't need to know. Typing is great, but it's optional. So TypeScript is better than Java. Object orientation is great, but it's optional. So TypeScript over Java. It's just TypeScript over Java all day. Java does not really win when it comes to interviews. Java does not win when it comes to a beginner-friendly language. Where you start to see Java winning is because it's really efficient. So when you're actually building commercial systems and you want to fail the build if the type isn't correct, and you want strict typing from day zero, and you want it to be fast, and you want it to be memory efficient and affordable, then Java is the coolest thing around in 2011. Nowadays, you can reach for like a Golang or a Rust, and you get all of those benefits without the JVM. So those are even better. But there's trade-offs all around. Like, depending who you ask, I would say Rust is not easy. I mean, depending on who you ask, some people think Rust is easier than Java. We got a really active chat. Hey, throw some likes on the video if you're here. I'm a software engineering student. My data structure and algo professor didn't teach it well. Does Leetcode help? No. If you had a poor professor, jumping into Leetcode is going to make your life harder. And I've actually seen this contribute to burnout. And I've actually seen people just like give up on programming because they went this route. If you had a poor teacher, here are a couple of solutions. One, try to find a better teacher. By the way, you can check out my bio, latterly.io, and we're starting small groups next month. We'll meet each Saturday. But the curriculum itself is open source, and you can join the Discord for free and chat with people there. Two, just start building projects in your portfolio is going to be much easier than diving into Leetcode. So when I have people learn Leetcode, it's because they already have the fundamentals. And if you have a bad professor, they might not have taught you about the fundamentals well. What does fundamentals mean? It means actually doing things. Loops, variable assignment, a control flow like if conditions and stuff like that. Defining functions, returning from functions, referencing, by ref, by val. All of these things you're going to learn like Mr. Miyagi. You're going to learn without knowing what it's called. You're just going to learn it by being able to build projects. You're going to have to declare functions. You're going to have to declare variables. You're going to have to learn, and the lessons will stick that way because you will see the pain point clearly and you'll be able to fix it. And that really drives home the ability to remember it. Then you'll already know the fundamentals. You won't have to learn them or memorize them. You'll just know them. And then when you come over to Leetcode, you focus on the patterns. Okay? It's the magic recipe. Write it down, get a pen, get a piece of paper, take notes. If you're too cool for paper, send yourself an email, type it out, send yourself an email. Learn the fundamentals with projects, learn the patterns with Leetcode. And you learn the fundamentals before the patterns. The patterns build on the fundamentals, okay? Dumb question, what about C++? It's not a dumb question. C++ is fantastic. It's terrible for Leetcode. It's harder than Java. It's awesome for game development where you need screaming high performance. But game developers don't really do Leetcode that much. I think game development is like a pretty rough career, but one of the silver linings is they don't do Leetcode that much. I'm a high school student. I'm learning C#. Do you know any websites I can use to better learn C#? I would point you to a boot camp, but if you're in high school, that might not make sense. Let's see, does Code Academy have C#? Yeah, maybe check out Code Academy. Maybe check out Code Academy. I will say, even more than Code Academy, I would recommend you just like learn a different language. So I know earlier I said you only need one language, and that's true. But if you're struggling to learn one language, that's different from knowing one language. And if you're struggling to learn one language, that is an indicator that maybe you should be learning a different language. So I recommend JavaScript and Python. And I really recommend JavaScript because you want to take one step to JavaScript, next step to TypeScript. That's going to unlock so much stuff. In Python world, equivalents do exist. So there's something called MyPyC. The problem is that it's still not standard in the Python industry to do MyPyC, which is kind of like the TypeScript of Python is one way to think about MyPyC. And Python, anyway, I don't want to go on a rant, but Python is like dragging you towards like data world, which is it's just a different job family. Not that it's bad, but if you're asking how to be a software engineer, you know. I like Java for Leetcode. Hey, stick with it. I'm not trying to shame you. If you're good at it, go for it. So the advice that I'm giving is to like people who kind of like don't know what to do. If you're already awesome, keep being awesome. And thanks for being here. Mojo's cool. What are we talking about? The comment just said Mojo. Like Mojo's cool. I wouldn't be using it in my Leetcode, but it's cool. What do game devs do? They build games, right? Graduated last summer with a CS degree, still no job. Any advice? Yeah, book a session with me because I'm not going to be able to fix that through TikTok comments. Go to latterly.io. Link is in my bio. Book a session. If you shoot me a DM, just drop $5 here and I'll do a session. That's like usually $80, but since I saw you here, if you do the pay what you can, I'll hook you up. Okay, let's get back to some code, shall we? We fixed 3-sum. Whoa, there's no way. Yeah, no, I didn't finish. I didn't do the no sort yet. So we wrote out the 2-sum in here, and we need to next make sure that we're passing arguments: nums, results, wrapper, index, final index. Nums, results, wrapper, index, final index. Is that all we need to pass? It looks like it. Here we will say if wrapper index is not 0, and that is going to guard me against my left out of bounds. That's why we do that. Or it is not a duplicate. Or it is not a duplicate. Wrapper, so we'll say nums. Wrapper idx is not equal to nums wrapper idx minus 1. So we have a new value. All right. Then in that case, let's run the 2-sum. That's right. And then when we're done with 2-sum, we want to increment the index. Nice. Last thing to do is say while. While what? While the wrapper index is less than the final index. What about the equals case? Why is it not less than or equals? kind of think it should be less than or equals. I don't know. Is my brain malfunctioning? Let's run it. TwoSum, missing a required positional argument. Okay, we missed an argument. Nums, results, target. We missed the target. Okay. So let's put in the target. And the target is going to be cur wrapper val. Oh, let's do this for the chat. Cur wrapper val. We'll pep 8 it. Cur wrapper val. Okay. And then cur wrapper val equals. Throw a line break in there. So now that we've repeated it, looking good. So my issue is around the sought. Okay. The issue, key error -1. Key error -1. Ah, okay. Python things. I think you can do the syntax that I wrote in JavaScript, and it would result in the value of undefined instead of throwing a key error, but Python will give you a key error. Time limit exceeded. Okay. We too slow. We too slow. So let's see. What can we do to speed this bad boy up? Maybe we can't, by the way, right? Like we're in the threesome for where the correct Leetcode solution is to sort. So I'm actually not sure if we're going to get a passing solution with the no sort option. But we should, because the performance is similar, right? It's just more memory. Okay, so we should. Did I do the same thing again? Why do I keep doing this? We need to dedent that wrapper index. No? Okay. Do I get rid of this? Does that help anybody? Doesn't look like it helped. Okay, so why the left index? Am I just not incrementing the left index? That's boneheaded. Okay. We're getting somewhere, right? We're not out of time. We're not out of time. So here's my output, 0, 1, -1. 0, 1, -1. Notice that these are out of order. Notice that these are out of order. And if we, yeah, this is actually the right answer if they were sorted and deduplicated. Do you see that? Because we are in no sort, I don't know ahead of time. So I don't know ahead of time that this is the proper order. And I was assuming that it was. That's a problem. So here I want to say sort. Is it sort? I don't know. There's some magic Python command to sort these. We'll figure it out. Sort, is it sorted? Is it sorted? Unhashable type list. That's okay. We're going to get there. We're just going to retuple the tuple. And then we're going to tuple it again. Unhashable type list. Let's break it out to its own line. Sorted. Oh, okay. Does the inside need to be a list? And I probably should break this out for readability. So we'll call this sorted subarray. Let's call this unsorted subarray. We'll start with the unsorted subarray. Okay. So here's the unsorted subarray. And now I will dot sort. Okay. That should sort it in place. By the way, this is only constant time because count is fixed. So that's a constant time set of operations. Nope. Can I cast it to a tuple now? We're going to get it. Don't worry. Don't give up on your dreams. Oh, bummer. Minus 1, 1, 2, minus 1, minus 1, 2. We're close. Do I need to reverse sought? I don't know that that's going to help us. Nums wrapper index, sought cur left. So will these three add to 0? We have the target. We have cur left. So target plus cur left is sought. Okay, so that's wrong, basically. Target cur left minus sought. Do you see? I'm just doing some algebra right here. So do you see? This is what we're finding. But if we wanted it to be 0, it would be target minus cur left minus sought. That's my line of thinking for testing this negative here. Okay, but it's still wrong. Bummer. Minus 1, 0. Minus 2. Let's see. What are we doing wrong here? We're in the ballpark, right? I think. I mean, unless I've lost my marbles. I think that these are these outputs, and they're just sort of like improperly scrambled. Let's check some other test cases to see if that looks true. All right, we passed the empty case. That's fine. 0, 0, 0. That's also like a contrived easy case. Ooh, why are we doing empty here? Ooh. What is the length of nums? Is nums allowed to be an empty list? We have a test case where they give us 0, 1, 1. We can just handle that ourselves. If length of nums is less than 3, return an empty list. So now we know that it will always have at least 3 elements. And so should we always add the first? No, of course not. Of course not. So while the wrapper index is less than the final, cool. If wrapper index is not equal to 0. Oh, is that supposed to be is equal to 0? If the wrapper index is equal to 0, or the current value Nickelodeon. Don't say that in your interview. If length of nums is less than 3, why is this failing? Okay, so if the wrapper index is 0, should pass now. So we're passing nums results cur wrapper val, wrapper index in the final. So now we're in here. Left index is the middle guy. And that's to the right of end index. Yes, it is. So I have my current number. And my sought number. So sought is going to excuse me, sought is target minus current left. So that's going to be 0. 0 is not in seen, else I'm going to set that I now have seen it, but it will never proceed. It will never proceed, and that's the issue, right? So why will it never proceed? So the left index gets incremented, and it's now equal to the end index. I think that's the issue. List index out of range, no? Okay, now while the previous left is equal to the current left, or, and left index is less than the final one. Okay, now we passed that third test case. All right, great. So this is better. This is better. Now that we're in this world, what do we see over here? Let me bring back my sought as it originally was. And expected -1, -1, 2. -1, 0, 1. So I'm inappropriately approving -1, -1, 0.
Coming with me.
Okay. Thoughts on Verilog? Not sure. I don't know what that is. Let's solve this problem, and then we'll wrap up. So the wrapper index of nums is giving us one of the values that should definitely be there. Okay. In our nums list, we can see that 2 is this value in one instance. And what would the other be? 0, I think. 0, I think. Okay. I'm actually not sure about that. We could run into any of them. So I could run into this -1 first, which I do. Then I find 0, 1. Yeah, that's the trinity right there. And we do find it, actually. We do find it. Okay. So we actually have that one. All right. Then we continue. And -1, 0. At some point, we add this additional -1, and that's a mistake. So there's an incorrect recording of that group of 3. I'm suspecting this true value here. I'm suspecting that we don't want to say that it's true, that rather we'd say seen cur left and then put the difference here. So let's think through that. So if I put the difference here, let's say I've run into the first -1. Okay. Then I look in the 0 and the 1. Great, that works. 2 doesn't work. 1, now I've hit the second -1. And I'm at the second -1, and what do? I am seeking a -1, am I not? I think so. I'm seeking it, and I say I've found it, so that's why I append it. So my cur left is 0. Actually, that's not the case when I run into this, because the 0 will be spent. The 0 will be spent. Zero, 1, 2, minus 1. I think I'm going to time box this to 2 more minutes and look up the answer. I think you hit 0, then find minus 1, but subtract minus 1, which gives you 0, but they don't sum up to 0. Yeah. And I feel like a solution is that I should change this true into a difference value, but I'm having trouble proving it. So, well, we showed that I can find this -1 twice. So let's see if it fixes the problem if it was a number instead. So where do I find this -1? So first I find the -1 just because it's the first, one that you start with. So it's my wrapper value. So I have my wrapper value as the 1. So I find my 0 and my 1. That's a match. And then I should be moving forward on the left. So I move forward on the left. So now I find this one. And now I have my left and my right both pointing at 1, which seems strange. Maybe I need to clear my scene map at that point. That's another option. Have you sorted the array? No, this is no sort. We're doing no sort. Stephanie, thanks for the follow. So we have 2 sort of guess fixes here, but I haven't proven them very well. What about checking sought equals cur left plus idx? Yeah, that's an option. Sought and seen, let's see. To do and check sum here. I'm thinking that we shouldn't have to check the sum. So why would I not have to check the sum? I would not have to check the sum if sought is not merely in scene. But if I already know that it's the target minus left cur, that should solve the problem. Actually, I shouldn't need to do any math at all. So how would it not be 0? Ooh, okay. I think scene cur left needs to be the index, because here I'm putting the value that's sought, but I want to put the I'm not sure if that's right. Okay, so we have 3 guess fixes. Let's try them out. We'll try to do a guess fix, and then if those don't work, we'll look up the solution. So maybe set diff not true. Maybe set idx not true. So we have a bunch of different guess fixes. I'll start with these 2. So scene cur left is true, and it's true at the left idx. Okay. So now that we loop back around, sought is in scene, which means that we have that value. But here, we're not going to use the value. We're going to use the index. Scene at. Okay. Now this shouldn't actually solve it because it should actually end up being the same value. Cur left. All right, let's try it. Yeah, so that doesn't solve it. It's equivalent basically. All right, so now we'll undo that. We tried setting to the index. We're going to eliminate that. What about if we set it to the diff? And so here, this will be target minus cur left. So when we saw cur left, then the value we wanted, okay? So here we'll say and checksum here, which is kind of equivalent. We'll say wanted equals seen sought. And then we'll say cur left if cur left equals wanted, which is basically equivalent to checking the sum. Let's indent all this stuff over here. And that didn't fix it either. Okay, we'll undo that. Put this back to true. We'll directly check the sum right here. So if sought and seen and cur left plus seen the sought value, that will just be a value of true. That will just be a value of true. If sought and seen and cur left plus sought is equal to target, how would it not be? Cur left plus sought. Yeah, literally it's just algebra. So I don't expect that to fix it either. Yeah, that's also wrong. All right, great. We'll undo that. Last thing we'll try is resetting the scene map. Scene is this. And that didn't fix it either. Okay, so none of those worked. And what we want to do is look up the no sort solution. Python no sort 3 sum. That's the one I just did over there. Could be a set, I think. Yeah, that's the one I just did. If the length is less than 3, return empty. We did that. Great. Result set, dupe set. Now this we didn't do. That's interesting. Record args to 2 sum for duplicates. The way we failed, though, did we fail on a duplicate? I don't think so. Maybe if duplicates is catching the 1, 1, but I don't think that's the purpose there. Output format, fine. For k in the range, we did a while loop, but that's going to be equivalent. If nums k not in dupes, if nums k not in dupes, that is our current wrapper value. So we're checking priv, but they're right. We should be checking dupes because the checking to priv assumes that we're sorted and we're not sorted. So this is a mistake already. So here we're going to note the mistake. Checking priv instead of global dupes, e.g. correct ref is over there. Thanks for the follow. Okay, so we have these dupes. We're checking they're not in dupes. Now we're going to add it so that next time we'll see it. We get the 2 sum for every s invalid sums. This is basically ordering those later on. Okay, so we took care of this, although we did it down here. So that's fine. So now let's look in our 2 sum. Solutions. We didn't call it solutions. We passed in results and appended to it. We passed in results and appended to it. So we can basically ignore that. Target is minus num's target index. We did the same thing, but we passed it in as an argument. That's fine. Complements. Okay, so we called it seen, and they called it complements, and that's great. You can tell the difference in the name. So mine is the Boolean indication if we've seen it or not, and theirs is the complement. In fact, I think I said to do should it be a diff. Complement, index of complement. Maybe multiple. All right, so that smells close, but the idea that there would be multiple is strange to me. I in the range of the target number. So this is similar to left index less than or equal to the end index. Cool. C is target minus nums of I. So I, in my case, will be the left index. So this is the complement, or what I called sought. I called it sought. So if sought in seen, all right, but they're saying if C in complements. Complement C is the index of the complementary value. I actually wrote that down, didn't I? At some point I had over here left IDX right there. So basically that's what they're doing. All right. For index in complements. This part is different. So they're doing a default dictionary that creates a list. And I only allowed there to be one. Solutions.append nums I nums index. That is so weird to me, dude. What I would expect this would do is theirs might have more results than mine. Nums I, nums index. That's confusing. I versus index. What is index? The current number may be a future complement. So how do they get over here? And because you need three elements in your result. So they get these valid sums, get all two sum sequences. Get all two sum sequences. For S invalid sums, so S here will be a tuple. Sorted nums K. If tuple R not in results, then add it. So this is like a deduplication basically. If the tuple R is not in results, I don't know why they even need to do that because I thought that would be done by built-in. Let's grab this and see what happens. I'm pretty baffled actually. I'm not seeing where the difference is. Okay, let's just write over this. Here we are changing the arguments now. Shift tab to move it to the left. Oh no, let's undo that because they're using self, so theirs is on the class, okay? They're passing nums and target index. Nums and target index. Okay, so this is going to be solutions as array. Okay, they just call it S. So we'll get the solutions as array. And then we sort it and make it a tuple. I'll say as tuple is sorted the 0, the 1, and the wrapper index. No, the wrapper value. Was that our issue? Were we swapping index and value? So now we have the tuple, and then this gets added to results, and they do some deduplication. I'm not really sure why I need to do that. Results.add of the as tuple. Expected 1 argument, got 3. Not supported between instances of int and list. Okay, that was a mistake. For cur pair in solutions as array. Cannot access local variable as tuple where it is not associated with a value. Oh. Was never closed. Nice. 1, 2, 3, 1, 2, 3. And that was accepted. All right, well, I'm over time. I'll be studying this later. Something in the to sort is the key difference. This deduplication is not the key difference. Something down here in the to sort, and I'll have to study that. Thanks for being here, and talk to you later.